Hey everyone, welcome to this video on fine tuning in deep learning. Today we will learn what fine tuning is, why it is useful, and how it works step by step. Let's get started. What is fine tuning? Fine tuning is a technique used in transfer learning. It means taking a pre trained model, one that's already learned from a big dataset, and then training it further on a new and specific task. Think of it like this: you have already learned how to ride a bike, now you just have to learn how to ride a scooter. You don't need to start from zero. For example, if a model has been trained to recognize general animals, we can fine tune it to classify dog breeds. Pretty cool, right? So, why should we use fine tuning? First, it saves a lot of time and computing power. Second, it gives better results because it uses already learned features. And third one is, it works well even if we don't have a lot of data. And finally, it makes it easy to adapt a model to a new problem without starting from scratch. Here is a simple overview of how fine tuning works. Step 1. Choose a pre-trained model. Step 2. Freeze some of its layers, usually the early ones. Step 3. Add new layers for your specific task. And fourth step is fine tune or train the full model on your data. That's it. Now let's break each of this down. The first step is to pick a model that's already trained on a big data set. Some popular ones are VGG, that is good for basic image tasks. Second is ResNet, it is useful for deep learning with skip connection. Third one is Inception, it is used for capturing multi-scale features. And last one is BERT, it is great for natural language tasks. Make sure the pre-trained model is related to your tasks for better results. Next, we freeze some of the pre-trained layers. Why? Because these layers have already learned useful patterns like edges, colors, and shapes in images, and we don't want to lose that. Freezing means the model won't update those layers during training. And step 3 is add new layers. Now we add some new layers to adapt the model to our task. This can be dense or fully connected layers, dropout layers to prevent overfitting, and finally an output layer depending on your task. For example, we use softmax for multi-class classification, sigmoid for binary classification, and linear for regression tasks. Once we have added the new layers, we start training the full model. We might unfreeze a few layers to let them adjust to the new task. We use backpropagation to update the model weights. Some quick tips are: start with fewer epochs, use a smaller learning rate so we don't lose earlier knowledge. Now, let's see optimization techniques. To get the best results and avoid overfitting, we use some extra techniques. Regularization, like dropout, weight decay, and early stopping. Next one is learning rate scheduling. It is used using lower learning rates for frozen layers and higher ones for new layers. And last one is monitoring. It always checks performance using a validation set and adjust if needed. Let's wrap it up. Fine tuning is a smart and powerful technique in deep learning. It helps us to work with limited data, save time and computation, and get great results quickly. It is used everywhere, like in image classification, NLP, medical imaging, and more. So, next time you face a new problem, don't start from scratch. Fine tune a model and get a head start. Thanks for watching.